Hi, I'm Greg Lytle, VP of Engineering at Ozone Technologies. In this video, I'm going to demonstrate how you can be quickly up and running in less than 5 minutes with the Maivin AI Starter Kit. The Maivin AI Starter Kit is a fully integrated modular reference design developed by Ozone, Toradex, and Vision Components, which you can use for prototyping and then field testing your embedded vision design with edge-based machine learning. The Maivin AI Starter Kit is based on NXP's IMX8M Plus application processor, which is ideal for many machine learning imaging use cases where a high level of performance and integration is key to meeting your project goals. The Maivin AI sensor is also fully supported by the EIQ Toolkit, which you can use to train your model or convert an existing machine learning model and then run it on the integrated NPU hardware accelerator for maximum performance and power efficiency. The platform is also ideal for evaluating Ozone's DeepView middleware, such as Vision Pack for optimized image pipeline processing, DeepView Model Pack for optimized NPU-based detection models, and DeepView Application Pack for highly efficient object tracking. Now let's open up the kit and get started.
The Maivin AI Starter Kit includes everything in the box you need to get up and running quickly. Here's the Maivin AI camera, and it's an enclosure. It includes an Ethernet jack, RS-45, CAN, and serial I/O on the rear terminal block connector. We include a USB dongle and a power adapter, as well as a desktop tripod for quick and easy testing. The tripod mounts on a standard 1/4 inch by 20 mounting screw on the bottom of the enclosure. We can then connect the Ethernet to the rear connector and plug in the USB RS-45 adapter into our laptop to obtain the IP address for the camera. We've included a deck of playing cards for testing and a 12-volt power supply for benchtop testing. We first open a terminal utility program to access the RS-45 port, where we have a utility running which displays the DHCP address which the camera sensor has obtained. In this case, you can see it's 10.10.40.177. I'll next show how, using the EIQ model tool, you can quickly download your pre-trained model and then validate the performance on the Maivin platform. In this case, I'm selecting a SSD detection model that was trained on ImageNet. We can profile the model. First, we'll check that the target IP address is correctly set up. Then we'll validate the model on the target. The model is then downloaded to the target, and a number of validations are performed on the target to determine the inference time. Here you can say the inference time is around 12 milliseconds running on the integrated accelerated NPU. We can now open a web browser by entering the IP address of the camera and see a real-time live streaming view with the metadata for the detection objects and bounding boxes displayed. In this case, the coffee cup keyboard and mouse, which are included in this particular detection model. The inference time, as well as the input and output processing time, are also displayed on the real-time view. Next, I'll show how we can test and validate a model which was developed using the EIQ portal. In this particular case, it's a detection model that was trained using playing cards. About 300 images were captured. The ground truths for the cards were defined, and the detection model was trained. We'll restore an existing training session for this model and remotely validate it on the Maivin platform. To remotely validate it on the Maivin platform, we just have to select the IP address for the particular target. In this case, it's predefined, so we can just select it. We then have to select post-training quantization for the integrated NPU. The model is then validated on the remote target, and a confusion matrix is displayed for the test images, which are located in the EIQ test set. Here you can see a good correlation between the ground truth and the detections that were performed. We can now open a web browser and look at the real-time view of the Maivin platform and test with physical real playing cards. You can now see with this new model which we've downloaded, the keyboard is no longer being detected, but the playing cards are. The integrated demo application streams the metadata for the detection results and timing to the web browser, where it's overlaid on the real-time video display. You can see on the display that the card's detection model has an inference time of about 7 milliseconds, which is extremely high performance for a low-power embedded edge device. This concludes the unboxing and setup of the Maivin platform. Thank you.